Yes, now come to question number 6. So, in this you can see on the right hand side that we have common ABC. Okay, so you can take out common A, B and C from C1, C2 and C3. Okay, so taking out common A, B and C from from C1, C2 and C3. Okay, so you have now A, B, C into A, then A plus B, then B, then here C and B and D plus C, and here A plus C, here A and here C. Okay, so now you see next what to do. So we have to now we want again common ABC. Okay, so now we will try to get some zeros. Okay, so now you can change this R2 to R2 minus R1 and also R3 to R3 minus R1. Okay, so let us change. Now we have ABC into R1 let me say A plus B and B. Oh, no, we are changing about this. Will be C and A plus C. Now change R2 to R2 minus R1. So R2 minus R1 will give you B. So this will be only B and this will be B minus C and this will be A minus this will be minus C. Okay, now changing R3 to R3 minus R1 gives you B minus A, then B, and then C minus A. Okay, now what to do? Again, you can just if you will add this 3, this C will be cancelled. Okay, now you can again change R1 to R1 plus R2 plus R3. Okay, so you will have ABC into all the 3 rows will be added, means A plus B and minus A means this will be cancelled and you will have now 2B. And here CC is cancelled, again here 2B, and here also CC is cancelled and also this A. So here you have 0. Then you have B minus A, B minus C, B minus C minus A. Okay. Now it is equal to taking out common 2 also from this row. You have twice of ABC, then 1. Okay, so you can take out common 2B also. Then you will be having this 2AB square C. Okay, now this will be B minus C, B minus A, B and minus A. Okay, now you will try to get one more 0 that you can get after subtracting this R1 to R1 minus R2. Okay, so now what you will get R1 minus R2. So you have now, so it is equal to twice of A B square C into then R1 minus R2 is not R1 minus R2. Change this C1 minus C2. Okay. Here we will write. So C1 minus C2. So you have 0, then B minus B, and this will be C, then B minus A, minus B means minus A. Okay, then 1, then B minus C, then B, and 0, minus C and A. So expanding about the R1, we have now it is equal to twice of A B square C into this minus 1 into minus AC and minus AC. Okay, so that is equal to twice of AC, that means 4 A square B square and C square, hence root. Okay, so complete this question. So now come to question number 7. So question number 7 is you are given A inverse and B and you have to find AB inverse. Okay. So from this A inverse you cannot find again A. So what you will do? You know this formula, De Morgan's law of class 11th, that is AB inverse is equal to B inverse A inverse. Okay, so you have B and A inverse. That means you have to find now B inverse. So this B inverse you can find by using B inverse is equal to 1 upon determinant of B into adjoint of B. Okay, so this you will find yourself and complete the question. Okay, now see the next question. That is you have a matrix A and you have to verify that adjoint of A ka inverse is equal to adjoint of A inverse. Okay, so now what you have to do is adjoint of A ka inverse aapko nikalna hai. Means this adjoint of A will be treated as matrix A. Means for finding the inverse, first we have to find its determinant and then inverse of this whole adjoint. So inverse of this adjoint of A will be what? It will be 1 upon determinant of adjoint of A into adjoint of C. So 1 upon, because you know that A inverse is equal to 1 upon determinant of A into adjoint of A. Okay. So this you can find now, and then for RHS you have to find adjoint of A inverse. Adjoint of A inverse means first find A inverse and then its adjoint by writing the cofactor matrix and then taking its transpose. Okay. So this all type of questions we already have done. So you complete up to this question. Now come to the next question, that is proof question number 9. So question number 9 is, now again you have to prove or find the value of any determinant. Okay. So question number 9 is, you have to evaluate this x, y, x plus y, y, x plus y, x, then x plus y, x and y. So you have to find its value. Okay. So you can observe one thing, that in all these columns or rows you have, when you will add this you will get 2x plus 2y. So you can change R1 to R1 plus R2 plus R3. Okay. So you what? Twice of x plus y. Here also twice of x plus y. Here also twice of x plus y. Then y, x plus y, x plus y, x and y. Okay, now taking out common, this 2 into x plus y, you have 1 and 1. Then here you have y, x plus y, x plus y, x and y. Okay, so now you can get 2 zeros from R1. Okay, so now you change this C1 to C1 minus C3 and also C2 to C2 minus C3. Okay, so you have, it is equal to twice of x plus y. So 1 minus 1, 0, y minus x, then x plus y minus y means x, then again C2 minus C3, you have 0, y and x minus y. Okay, then 1, x and y. Now expanding about R1. Okay, so you have twice of x plus y into, this will be 1 into y minus x into x minus y minus x. Okay, so it is equal to twice of x plus y into minus of x square minus y square minus x square. Okay, so this is the final solution what you want. Okay, or you can expand it further also to one more step. Okay, come to next question now. So question number 10 is, all of you complete this question. Now question number 10 is, you have to evaluate 1, then x plus y, x, y and x plus y. Okay, so now again you have 3 ones in C1. So you can make this 2 ones equal to 0. So you can change C1 to, no, you can change now R1 to R1 minus R3 and also R2 to R2 minus R3. Okay, so you have R1 minus R3 means 0 and x, y minus x. Okay, then R2 minus R3 means 0, y and minus x, then 1, x and x plus y. Okay, so now expand about either I1, R1 or C1. So expanding about C1. So you have 1 into 0 plus xy. So that is equal to finally xy. Okay, is it clear? Now question number 12 is you have to show that this determinant is equal to 1 plus px by z, x minus 5, y minus z into z minus x. So you will observe here that this column C3 is expressed as the sum of two terms. So you can express this whole determinant as the sum of two determinants, isn't it? So that we have already seen in the properties. So now you can write this determinant as x, y, z, x square, y square, z square, and 1, 1, 1 plus again x, y, z, x square, y square, z square, and px cube, py cube, and pz cube. Okay? So now this determinant will remain same. You have x, y, z, x square, y square, z square, 1, 1, 1. And here you can take out common x from this row, y from this row, and z from this row, and also p from this column. So taking out common p, x, y, and z, you have now 1, 1, 1. Now we have taken out from here x, so it will be x and x square, then y and y square, then z and z square. Okay. Now you can interchange this two columns, that is 1, 1 will come here, and then again after interchanging this C1 and C3. So if you will change first C1 and C3, so you will get this determinant multiplied by -1. And again, if you will change C2 and C3, okay, you will get the same determinant. Okay, so you will get 1, 1, 1, x, y, z, x square, y square, z square, plus p, x, y, z into 1, 1, 1, x, y, z, x square, y square, and z square. Okay. Now this is common in both, so it will be equal to 1 plus p, x, y, z into 1, 1, 1, x, y, z, x square, y square, and z square. Now you can get two zeros in this C1. So you change R1 to R1 minus R3, and also R2 to R2 minus R3. Okay. So it is equal to 1 plus p, x, y, z into R1 minus R3 means 0, x minus z, x square minus z square, then 0, y minus z, y square minus z square, then 1, z and z square. So taking out common from these two rows, you have x minus z, y minus z into 1 plus p, x, y, z. You have 0, 1, x plus z, 0, 1, y plus z, and 1, z and z square. Okay. So now you can expand about this C1 to get the proof. Okay. Because we have two zeros in C1, so I could expand about C1. Okay. Now computation number R2 to R2 minus 2 R1 to get 1 0 here, and also R3 to R3 minus 3 R1. Okay, so now let us find R1 is same 1 plus P 1 plus P plus Q, then this will be R2 minus 2 R1, then 3 plus 2P minus 2 minus 2P, so it will be 1. Then 4, here we can do, it is 4 plus 3P plus 2Q minus 2 minus 2P and minus 2Q. So we have now, here it will be 4 minus 2 is 2, then 3P minus 2P means minus P, then 2Q minus 2Q. Okay, 0. So now come to R3. Again it will be 0. So R3 minus 3R1. So 6 plus 3P minus 3 minus 3P. So it will be 3. Then we have 10 plus 6P plus 3Q minus 10, 3 minus 3P and minus 3Q. Okay, so it will be 7 plus 3P. Okay, now expanding about C1. You have 1 into 7 plus 3P minus 6 plus minus so it will be 7 plus 3P and you have to prove it equal to 1. So you have now this is equal to 1 and maybe we are making some mistake in the sign. We will check again. So here we have 7 3P 3Q. Okay. Then we have 1 into 7 plus 3P minus 3 into this 2 minus P. So that will be plus 3P. But in the answer we are getting this. Okay, so what we have to do? This 7 minus 3P. Is it 7 plus 3P or minus 3P? So it is 7 plus 3P only, and then again here also we have to check. Is it 2 minus P? It is 2 plus P because it is 3P minus 2P. Okay, 2 plus P. Okay, so here now you will get minus 3P. So these two are cancelled and that is equal to 1. Okay, so now come to the next question. Question number 15. So question number 15 is, now you have sin alpha, sin beta, sin alpha, sin beta and sin delta, no, sin gamma. Then cos alpha, cos beta and cos gamma. Then cos alpha plus beta, no, cos alpha plus delta. Then cos beta plus delta, then cos gamma plus delta, and you have to show it equal to 0. So what is the formula of cos A plus B? It is equal to cos A cos B minus sin A sin B. So we will write the formula: sin alpha, sin beta, sin gamma, cos alpha, cos beta and cos gamma. And here in place of this you will write cos A, cos B minus sin A, sin B. Okay? So now this will be cos A, cos B minus sin A, sin B, then cos A, cos B minus sin A, sin B. Here also cos A, cos delta minus sin delta. Okay, now let us split this determinant using the properties. So it will be sin alpha, sin beta, sin gamma, cos alpha, cos beta and cos gamma. Then cos alpha, cos delta, then cos beta, cos delta, then cos gamma and cos delta minus sin alpha, cos alpha, sin beta, cos beta, then sin gamma, cos gamma, then sin alpha, sin delta, sin beta, sin delta, sin gamma and sin delta. Now you have to move it equal to 0. See, here you will find that if you will take out common cos delta from this, then these two columns will become equal. And here also, if you will take out common sin delta, then these two columns will become equal. Okay, that means 0 plus 0, that is again equal to 0. Okay, so in this way you will complete this miscellaneous exercise. Few questions I have left because that were easy, and this type of questions we have already done. Okay, so the remaining questions you complete by yourself. If you have any doubt, then you can ask me.